Hi guys, so we're going to see pKa and pKb in calculations. Now the pH scale represents very small concentrations so that it's easy to interpret. So similarly, because Ka and Kb values are very small values, we're going to introduce a log scale to the base of 10 to Ka and Kb so that the values can be easily compared. So just like pH is equal to minus log of H plus concentration, pKa is going to be minus log of Ka. And from the same reasoning, pKb is equal to minus log of Kb. Now you can also find Ka from pKa values. So Ka would be 10 to the power of minus pKa and Kb would be 10 to the power of minus pKb. Now pKa and pKb values, they are positive values, they have no units, and the relationship between Ka and pKa, Kb and pKb are inverse, just like H plus and pH, OH minus concentration and pOH. So similarly, you have the same relationship. So a strong acid is going to have a large Ka value, and a weak acid will have a small Ka value. But a weak acid will have a larger pKa value, and a strong acid will have a small pKa value. And for bases, a weak base is going to have a small Kb value, and a strong base will have a large Kb and a small pKb value. So just that you can compare and understand better. So a strong acid, if you look at the pH, so a strong acid will have small pH values and a weak acid will have larger pH values. When we talk about pKa definitely means that it's a weak acid, but when you compare pKa values, smaller pKa values means that it's a stronger acid, weak acid but stronger, and a larger pKa value means that it's a weaker acid. And when we're talking about pKb, we definitely mean that it's a weak base. So if we look at the pOH scale, a small pOH value means that it's a strong base, and a larger pOH value means that it's a weaker base. The next point important to note is that a change of 1 unit in pKa or pKb value results in a 10-fold change. So the same thing applies on a pH or a pOH scale. So this is because of the logarithm scale to the base of 10. So if you have one weak acid with a pKa of, let's say, 1 and another one with a pKa of, let's say, 2, so the difference between the pKa value, so you have 1 unit, therefore it's going to be 10 to the power of 1, so a 10-fold change. If the difference is so let's say pKa value is 5, so here the difference is 4, therefore you will have a 10 to the power of 4-fold, which is going to be 10,000 times. So this is going to be 10,000 times weaker compared to this acid. The next point is that pKa and pKv values should be quoted at specific temperatures. These are temperature dependent values. Let's see the worked example. Here the answer is wrong here. So calculate the pH of a solution of methanoic acid. So the pKa value is given. Now pKa values can also be found in section 21 of the data booklet. So for your exams, you might just be given the question, find the pH of methanoic acid. You might just not be given this. So you can be given the temperature, and that's it. So for this, so pKa 3.75, therefore we can get the Ka value from this, and you know that Ka Ka would be given by H square over Ha. So from this you can find concentration of hydrogen. So it's just the concentration of the acid times square root of this. So that would be, and then from the H plus you can get the pH. So pH is minus log of concentration of H plus. So if you do this, you should get the pH of 1.92. So you can move on to the next question.